You'll remember in chapter 1 that we discussed the hierarchy of organization, and we said that subatomic particles get together to produce atoms, atoms get together to produce molecules, molecules get together to produce macromolecules. Well, we want to start our discussion today on the level of atoms and subatomic particles. So the question is, where do we find information about atoms? And the answer is the periodic table. And this figure shows you just a specific section of the periodic table that presents elements that we'll be working with in more detail this quarter. So let me just familiarize you with features of this periodic table. Each block of the periodic table represents one element. The element's name is given, as well as its appropriate symbol. And you'll remember in the reading study guide I've asked you to learn the names of selected symbols, so please refer back to that. There are two pieces of additional information provided in each block. The first is a whole number, which is the atomic number, and the bottom number is referred to as the atomic weight or the atomic mass. The atomic number gives us the number of protons in an atom of that element. The atomic mass gives us the combined number of protons and neutrons in an element of that particular atom. So, for example, if we look at helium, helium has an atomic number of 2 and an atomic weight of 4. That means it has 2 protons, and if we take the weight minus the atomic number, 4 minus 2, that gives me the number of neutrons. Because remember, the atomic number is the number of protons. The mass, you'll remember, of a proton and a neutron is 1. Therefore, if I take the atomic weight and subtract the atomic number, what I have left is the number of neutrons. And again, the weight of each of those being 1. So another example, if we look at fluorine, for example, fluorine has an atomic number of 9 and an atomic weight of 19. So if we take the difference, which represents 10 units, those 10 units would indicate 10 neutrons would be present in an element of this particular atom. Now you'll remember that atoms are electrically neutral. Remember, the only subatomic particles that have charges are protons and electrons. So if atoms are electrically neutral, not only does the atomic number tell us the number of protons, but it also tells us the number of electrons. So for example, in an atom of fluorine, we have 9 protons, therefore we also have 9 electrons. In an atom of nitrogen, we have 7 protons, we also have 7 electrons. So if we look at boron, we can address all 3 subatomic particles. The atomic number, which is 5, by definition gives me the number of protons. The number of protons is also equal to the number of electrons because, again, atoms are electrically neutral. So boron has 5 protons and 5 electrons. We said to get the number of neutrons, we take the difference between the atomic weight and the atomic number. So 11 minus 5 is equal to 6. So an atom of boron has 5 protons, 5 electrons, and 6 neutrons. You should feel comfortable doing this process with any element on the periodic table. Now, one additional point to make, you'll notice that some elements, the atomic weight is not a whole number. It's a decimal. Don't worry about this. What I would ask you to do in calculations is to round. In other words, if the value is 0.5 or less, I would ask you to round down. If it's greater than 0.5, I'd ask you to round up. So we would treat silicon as having an atomic weight of 28. We would treat chlorine as having an atomic weight of 35.